Okay. 1-1. Check, check. Okay, I see the reaction. So I conclude that everyone can hear me. Okay, so guys, if you want, you can go on air so we can talk. As far as I know, settings of this meeting allow you to do this without my permission. So you can hit go on air, выйти в эфир. If all the instructions are in Russian in your webinar. And we're going to talk. What do you think? I'm still alone in there. Okay.
Okay.
Yeah, hi.
Hi.
By the way, it's okay if you keep your cameras off. It's not necessary to show me your presence. It's okay. I understand everything. But if you're okay with this, please do. I think it's going to be much nicer to see each other during the conversation, right? Okay. So I see 3 of you. Hi. Hi, hi. Anyone else? Guys, come on. I'll give you extra 2 minutes. Okay. Okay. So, by the way, you can find a link to the collab notebook from relevant lecture. This is a collab on lecture number 2 on estimation, value at risk, and expected shortfall. So, I guess most of you have already copied it to your Google Drive. Okay. And I recommend to use it today because the seminar, the plan for the seminar is the following. I will give you some directions about which data to use because we're going to follow the quite similar example as on the lecture. So we're gonna use another stock, just with another ticker and another historical horizon to construct our portfolio. Simple one. We also modify the sensitivity of our resultant portfolio to the key risk factors, because on the lecture we considered the case when negative return were corresponding to our losses, but at the same time we can have, for example, we can take opposite position, which is a short position, right, and experience losses from prices going up, right? So this is kind of different setting. And we're going to follow the steps of the workflow we've seen today. And I'm going to specify some parameters of the expected shortfall, what the confidence level should be, what do you have to do with returns, what do you have to do, which method of calculation you should pick. You will also go with your own decision, for example, like picking distribution. All right. So let's start. Okay. Um, I think I'll share the screen with you, but the most of the time, I expect you share screen with me. Okay. Because I'm going to write down some tasks in the collab, and I expect you that you spend some time coding yourself, um, like a 7 or 10 minutes, and after that, we go and have a discussion what we come up with. All right, good. Any questions so far? No, great. So we moving on. Great. Okay, so I hope you have already downloaded notebook from the lecture. And now I'm going to write down some short task for you. So using collab, this is going to be first task. Using notebook from the lecture. Please download daily price data on Tesla Corporation. I will provide you with a ticker right now. Don't remember exactly what it is, but here we go. Here's a ticker, TSLA. All right. So from January 1st of 2020 to current date. Current date, right? And construct series of daily returns. Okay. I think I'm gonna give you like 7 minutes for this, and then we're going back in there and see what the results are. Okay. So all the code you can get from the notebook. Should we use only Collab, or it's okay to use Jupyter Notebook? It's okay to use Jupyter Notebook. By the way, Collab Notebook, it's a Jupyter Notebook as well. So if you download it from the Collab, you going to obtain plain notebook, IPyNB. Okay, but if you work locally, it's absolutely fine. I don't mind. It's absolutely up to you which software or IDE to use. Should we work in a lecture file? You can work in a lecture file if you would like. So for example, if you can adopt the code from the lecture, that's absolutely fine. As I was saying, the syllabus of the course does not assume the technical expertise in coding. So it's absolutely fine if you understand the code particular realization and can adopt it in new context. All right. Okay. I'm not going to bother you and turn off my mic as well. If you have a question, post it in questions or feel free to turn on your mic and speak out loud.
Excuse me. And the choice of type of returns is up to us, or we just use the same we used on lecture?
It's absolutely up to you.
Okay.
Just please just be specific which style of return you pick.
Okay.
Okay. I would generalize the idea if you want me to do this. Um, if we deal with a single stock and we uh, work with them on a portfolio level just for a single period of time, it's much easier to deal with the arithmetical returns, just the simple returns. It's okay, absolutely fine. But for example, if we deal with aggregation risk over time, and if we analyze some um, derivative instruments, uh, and value of those derivatives is depends on returns of stocks, it's much easier to use log returns rather than simple. So I would say in this particular case, it would be rather natural to use simple returns. But if you use log returns, it's absolutely fine. Just be specific.
Okay.
Yeah, and please notice I put a little extra task in the first one. Um, it is one-liner, so you can just copy the code from the collab just to visualize returns with a serial plot and histogram just to see the how realized returns behave over time and how the general distribution will look like. If someone has preliminary results, feel free to share it with us. Oh, Evgenia, are you ready to share your results with us?
If we speak about first part of seminar, yes, of course.
Okay, let's see it.
Well, I've imported few libraries and I've downloaded the codes, but I'm not sure about the starting date. Can you remind me about this?
I think it's correct. At least you can check the number of rows in your data frame after downloading the data. And that
I've just forgot.
It was 2020.
you
what
mean,
was
yeah,
that?
2020. Yeah, 2020. 1st of January of 2020. So the historical period starts with 2020 101. So if you don't mind, update your notebook. Nope. I can't see anything. So how's it going?
You can see my screen?
Nope. Can anyone else? Because I see black square.
We can
Really?
see.
Yeah, I can see the
But
screen.
it's
I
stuck.
was sharing for last
Yeah, for me it looks like
minute.
it's stuck a little.
Really? Oh, well, I
Yeah.
don't really know what to do with this.
Yeah, actually you can abort the demonstration and try to demonstrate it again. So it's a
Let's
simple
try it
recipe. Have you
this
tried to
way.
turn it off and on again?
Of course.
Yep.
Maybe now.
Yeah.
It.
Everything
Right.
looks fine. So let's see. Okay, here is the path. Here is the trajectory. Okay.
So this is just the plot of prices.
Okay.
Adjusted close. And this is the plot of daily returns.
Okay. And this is the
And
time
that's
series
the
of
histogram.
returns. Nice. Okay. So yeah, great. It looks pretty fine. Just be specific which style of returns you pick.
I've
Just
taken
a regular
adjusted
ones,
close.
just the simple ones.
Adjust close, and I haven't logged them, so I wasn't using logarithm.
Okay. Okay, fine.
Just returned.
All right. Yeah, it looks pretty good. I think that everyone else should get something like that. Any other results different from what we see?
No, the same.
Well, great. That means that we're going to see similar results further. Okay. Now I'm going back to okay, I'm going back to my screen. And now let's do some calculation of value at risk and expected shortfall for the empirical distribution. So as I was saying before, we can actually come up with the different models, and the most assumption-free model, which is free of assumption any particular type of distribution, is just an empirical distribution. So I have this series of tasks for you. First, let's specify confidence level. Confidence level of var and expected shortfall. Let's work with something extraordinary like 97.5%. So this is a kind of level we often use for hypothesis testing. Okay. Okay. Now we use estimation methods. Estimation methods. Method empirical. Empirical. So I kind of lost my. Okay. So, oops, here it is. Okay. Empirical one. So we deal with just empirical distribution. Portfolios deal with are. So the first one is going to be plain long position in stock. For those who doesn't know, the long position is just buying stock. So you gain when this price goes up and you lose when prices go down. So when the value of the position falls, all right? Another option is going short. On stock. And that means that actually you sell stock that you just borrowed. It means that you go into gain when prices go down, and in contrast lose money if the value of the position goes up. All right? So what actually that means? That means that for position A, the long position, you have to find value at risk and expected shortfall on the left tail of the distribution, all right? So in the negative zone of returns. For the position B, the short position, you actually afraid of positive returns on stock. So technically, your losses are represented by positive returns, and outcomes where you have to search for value at risk and expected shortfall actually lie in right tail of the distribution. Okay, so here's the deal. The essence of this task is to run your calculations on both tails of the empirical distribution and see the difference, okay? Is that clear?
Yes, it is.
Great. So I think you have roughly 10 minutes.
And we should choose a distribution, so just
No,
by...
you just work with the empirical distribution.
Okay.
Okay, so everything that, so just distribution, including observations from the past, all right? So this is a discrete distribution. So you should apply quantile method, you should apply mean over observations greater than value at risk. Just be careful about the level, all right? Remember that in this task, the level of confidence is 97.5, okay? So you have to explicitly put into the formula which weight you should leave on the left when you apply quantile measures, all right? So if you work on a left tail, you're gonna put there something like 2.5%, right? But when you work on a right tail, how much you should put into the formula? Taking into account that quantile is defined by the probability mass lying on the left from the quantile. Okay? Great. Okay, here is a question from Evgenia. So in short position, we used just returns quantile 1 minus level without minus. I don't seem to be sure that I understand the question. Well, let me tell you this. So you have two options dealing with the right tail of the distribution. You can do either apply the same formula, but use another probability, all right? So for example, if you work on a left tail and you are interested in a 99% var, so you put 1%, right, into the formula of the quantile, right? Because you try to cut 1% of probability on the left tail, right, in a negative zone. But if you're searching for the quantile on the right tail, you put there 99%. All right, because the quantile by definition is defined by the probability mass on the left from it. All right. Another option, you can actually multiply the entire series of returns by -0. So you invert return series itself and then apply the regular quantile formula with 1% as an argument. So you can either go rigorously on applying your formula, or you can invert the series of returns and apply the same formula. Okay? Okay, Evgenia, got it? By the way, I would like to make one more remark. Please make sure that when you calculate your returns, your data frame or index is sorted accordingly, because remember, you calculate return basing on previous price. So that means you have to take current price, subtract previous one, and divide by the previous one. But sometimes you may be not very accurate and change the places of those two prices in the numerator. So you kind of consider not the change of the current price in respect to the previous one, but rather than previous one in respect to current one. Actually, it will result in missing and kind of manipulating the data, and every time that you are supposed to see loss, you're going to see the profit, and vice versa. Okay, so please be accurate and very careful about how your data table is sorted. Most of the operations in pandas executed according to the index. So if your index is a date, so usually you don't have to worry about this too much, just to always do the double check that everything is correct, all right? But for example, if you do this in Excel, you have to be very careful about what you do. Okay, guys, so does anyone have preliminary results to share with us?
Before anyone is going to share, I would like to ask you again to explain about the quantile. I understand the idea, so that in one case we should use 1 minus our level, and in another case just level. But in which case which to use?
Okay. Let me explain it to you with the materials from seminar. Okay. Here we are. Okay. So can you see the distribution on the screen?
Yes.
Okay, great. Look, this particular picture is constructed for the returns. So the returns on stock, the positive part of this axis represent profits on long position, and negative one represents losses on long position. All right. So if we talk about long position, we are concerned about negative part of this axis, and that means that we trying to find our risk measures on the left tail, right? So if we would like to estimate value at risk and the confidence level of the risk, of the value at risk is 99%, that means that we looking for the level that won't be exceeded in terms of magnitude of the losses with at least 99% of probability, right? So that means that to the right side from this quantity, 99% of probability should be concentrated and the 1% in a tail, right? Right. And now we come up to the applying quantile function. Quantile, by definition, is the value that has particular probability mass on the left. All right. So if the confidence interval, confidence level in this in this settings 99%, it means that 99% should be to the right from the var and 1% to the left. So if I'm trying to find quantile on the left tail, I should put 1% on the left, right? Now let's consider the short position. The picture is opposite, and I'm trying to find quantile on the right tail, right here. But the definition of quantile is still the same. It's defined by the level of the weight on the left. But if I'm considering short position, the confidence level means that 99% should be to the left right? To the value on right tail. So if I'm trying to find value at risk for short position, which suffers from large positive returns, I should find quantile by putting 99% into the formula, all right?
All right.
So is it the same how you imagine it?
Yes, it is.
Okay, great. So if you don't mind, could you show us your results if they are ready?
They are suspicious, but I can show them.
Well, we're just learning, and we learn from mistakes, and sometimes suspicious results are the correct. They just contradict our intuition. That means that our intuition is wrong and not the data. Okay, now let's take a look.
So I don't
So-
have a graph, but I have some calculations.
Okay, so you have confidence interval. It's 0.975. Okay, great.
Yes, and for long position, I use 1 minus this level, and for short
Okay.
position, just this level.
Okay, so you telling me that 8% this is something that we should expect?
Maybe I'm just printing something else.
Do you have a picture for a time series of returns? Can we take a look at them? Okay, so here's a histogram.
Yes, and here is the plot.
Okay, and here's some. Well, the scale of the returns are pretty large, actually. So we can see very large jumps up and downs, like 20% up or 20% down
Yes.
daily. So 8% should not actually terrify us too much or make us too suspicious, but I think the numbers are pretty consistent with the data that we see on the graph.
I'm
Okay.
just not sure about the histogram, because it is obvious that histogram is not the same to the left and to the right, and still
Okay, I would say that the workflow itself is fine, but I would make a little correction corresponding to short position. Look at the interpolation.
it's higher. It should be
Yeah, it's
low,
higher,
right?
but I would put lower here because now I'm trying to go from the other side. All right, and this setting absolutely replicates the idea that I can just invert returns by multiplying it with a -1 and see the result. Something
went wrong.
Something
about this format. It should not include my variables, right? It's just var and es.
Yeah.
Could you please look at the chat?
No. Yeah, I look at the chat in a
if we change minuses and
hold on a second. Here's the deal, Nikolai. Look at the expected shortfall formula. It actually has something to do with the variable var, but your variable actually is called var long or var short. So actually you you filter the returns inside calculating expected shortfall relative to some quantity. I have no idea, nothing about it. So what it is?
It is, I guess, the variable from the lecture. So yes.
Okay, yeah. So first of all, let's take a look.
It's strange.
Yeah, it is suspicious now. Yeah, because no, because look at this. Look at this. You're printing var and expected shortfall. So you have to specify the names of quantities you try to print pretty accurately, because look, var long and expected shortfall long. So in a print, you should put var long and expected shortfall into the format with the same names. All right. Okay, now I'm going to go through the questions in chat. Level 2005, var return quantile interpolation higher. Expected shortfall returns greater than var. Is it for short position, Darina?
Yes. So if we change levels.
Okay. The only criticism is that interpolation should be lower.
It doesn't change anything really.
Well, it shouldn't change
The picture.
expected shortfall value. It's clear, but it may change var.
I see. Thank you.
So it's not a big mistake. It's just, when you can save money, you should save money, right? So there is no need to put extra capital. That's why we usually try to find something.
Yeah, thank you.
Okay. Okay, and var and expected shortfall looks pretty nice. Does anyone come up with the same numbers? Should have opposite numbers. Evgenia says I have minus 8.32 and minus 11.86. While numbers of three people are different. Let's find it out. So let's start with a long position. So what we're gonna do? We apply the formula that is implemented by Nikolai here. So I think it is correct. At least I don't see anything wrong in it. Now let's take a look at the expected shortfall. So we know that negative values of returns are losses, and we should find more extreme losses that are more extreme that found var value, right? Technically, var long is positive, so we should take negative value of var long, right? And find returns that are less than var long. Okay, so now I think your calculations are correct, and everything that we need to do now is make sure that we put right names into the print. Well, it looks fine for me. All right, and I see Evgenia validates those numbers as well. So thank you, Evgenia. Darina as well. Mikhail has the same results. Fine. Now let's go to the short position. So var short, we actually concerned about the positive side of the returns. So what we can do now? So we use quantile. We apply confidence level. So 97.5% should be on the left-hand side from this value. And interpolation should be lower. And we don't need put minus here because actually we're going to obtain positive values. So no. I mean in first line where you calculate var short, right? Just to be on the same page all over the process. So we just agree that all the calculations should end up with positive values. Okay. So right, it is 10.20. Agree. I agree. Now we move to the expected shortfall. So now we deal with the right-hand side. We are afraid of extremely positive returns, right? So every time when we see amazing profits on Tesla, we go into cry and curse the fortune. All right. So we try to identify all the observations on the right tail. In this case, we have to find returns that are greater than var short, greater, and calculate them in. All right. Now let's take a look. Yeah, I think now we have correct results. At least I can see the same results from Darina, from Mikhail. Yeah. So at least two independent opinions validate this result as well. So we can see that for this particular paper, for this particular stock, we see more risk on a daily basis arising from price rises rather than downfalls. It's kind of interesting. But now let's take another look at this problem. How about now we consider slightly different sample. So here our sample starts from 1st January of 2020, right? Let's exclude first of half year of 2020. So let our sample start from 1st July of 2020. So we slightly modify the sample, the structure of the sample. And let's run the same calculations and see how things again are going to change. Because actually we understand that it might be very different. So let's take a look. Okay, so here is number 3. Let's change sample. And see how R and
We are ready.
Great. Let's have a look. And if you don't mind, provide commentary on the result as well.
Well, they are lower. The level of the risk, and it's probably because of COVID-19 situation that was spring that year.
So you provided the results in the chat, right? So you're not.
Yeah, but I can
Okay.
show the screen, but it's just the same.
Okay, it's totally fine because if everyone feels comfortable to read it from chat, I feel comfortable. I'm okay with this.
Mm-hmm.
So we see slightly different, and there are less than we observed previously, right?
Yep. Yes, less.
And how do you think why we observe it this way?
The beginning of 2020 was highly influenced by COVID-19, and by summer, that influence has fallen a bit.
Yeah, exactly. And that's the lesson that we should learn from this task. Actually, as probably you remember from the lecture, when you throw out extreme events from your sample, you actually rebalance, you change the balance of extreme events and typical events. So for example, if you kick out of your sample like a crisis period, you go into find yourself left with moderate environment and let's say not very harsh returns, so less volatile market. And so every time when you deal with historical simulation and empirical estimation of the VAR and expected shortfall, you should be very careful about the structure of the sample because it might be manipulated by cherry picking of historical data. All right. So as you can see, we just dropped pretty volatile period, which actually may reappear now in the closest future. We don't know. That's just what we saw in the past. But throwing it away might change our perception about the future risk. All right. So this might be a solution for invalid model that produce underestimated risks, that underestimate risks of future, to put additional observations from the past from severe periods. Okay. All right, now let's do the fitting of the data with some continuous distribution. How do you think about it? So during the lecture, we tried normal distribution and we tried test student. Both those distributions are symmetric. So probably you can guess that no matter which side of the return distribution we deal with, applying those distributions will produce the same results on the both sides, just because the distribution is symmetric. But now let's take a look at the asymmetric distribution. I'm going to provide you with some ideas which distribution we may use. Okay, hold on 1 second. Okay. And I'll share my screen with you. So here is it. Here it is. Okay, come on. Okay. So here is a description of the module stats that we use. And here you can find the list of continuous distribution that are implemented in this module. So you can see here, for example, T distribution that we've been using. You can find here skewed norm, skew normal random variable. You can see another other distributions. I would recommend you to use, let's use distribution, one distribution from my case here. Which distribution did I use? Okay, I used Wright-Gumbel distribution. It's slightly skewed right here. So it looks like this. And I offer you to, and I suggest you to fit this distribution and try to calculate VAR and expected shortfall on the same confidence level for left tail and the right tail, so for the both positions, long and short, and see what's the results are going to be. Okay. So here is a distribution, stats Gumbel R. Yeah, because the idea of this distribution is that right tail is much heavier than left one, which used to be the case of our distribution. Well, maybe it's not going to look very
Again, show the function name, please.
Here's a Gumbel R, Gumbel underscore R. Right skewed Gumbel continuous distribution. Let me share a reference with you so you can find it chat right now. Okay. Yeah, I know that time of the seminar is up, and for those who need to leave, you feel free to leave. If someone wants to stay and work a little longer, I don't mind. I'm going to stay with you. But those who need to go, you're free to go. We'll go into anyway, we're recording this seminar and you can watch it later. Absolutely, it's absolutely fine. And by the way, I'm encouraging you to share your notebooks with each other. I don't think that you should be too greedy on on your materials. It's absolutely fine. And I think we're gonna post the material of this seminar to the LMS as well. Not only the video, but the notebook as well. So you can follow up and work on your mistakes or something that you missed. Okay. But I'm still here for 5 additional minutes. So if you would like to work and share the results with us, it's great.
I have a question.
Yep.
So, for some reason, my notebook writes that module. Okay, may I just show you?
Yeah, sure. Gregorio, yeah, sure. I understand you can go for another class. And thank you for being with us. You can watch the end of this seminar later in LMS, so everything is fine. Okay, so what happened there? Sounds good. Let me see. Yeah, it's kind of strange. Let me see. Attribute error. So has no attribute. It's just a typo because not Gumble but Gumbel. That's okay.